Welcome. I'm Bill Wake. This is my summary of our last week's work on Twitch. We're working on a programming language called 10th, and we're implementing it in ARM64 assembly language. Last week, we implemented search in the dictionary. We started doing some tokenizing to break words, a string of words into individual words. We implemented eval, and in there we added the facility to detect incorrect words. And finally, we put together a very simple REPL, a read eval print loop, and I'll give a demo at the end. 38 through 40, those are a prologue. We have to save any registers we use. And then we're given the address of the string to search for, and we're going to hold that in X11. We use X11 because we know that register will be held through the life of this routine. X0 tends to be more of a temp. Next line, 43, we're saving X10 is going to be the value of the pointer to the system dictionary. So the pointer to the system dictionary is the start of the linked list for the dictionary. X10 is going to be our cursor walking through it. Keep looking is the top of our loop. We're going to look at the system dictionary address. If we've gone back that far, then we know we haven't found the word anywhere. So we'll branch to L not found, that's over in line 63, and it just returns a 0. So rather than a pointer to the value we find, it just returns a 0, kind of a null, and exits. If we're not at the end of the dictionary, we're going to see if we match. So X0 points to our search string, and then we're going to load the value at X10 offset by 8. That's a pointer to the string, the name of the entry in the dictionary. So if we're looking for dupe, DUP, and we find that name there, we do a call to string equal to see if they match. If they do, then we jump over to L found. L found is over on the right in line 59. It's going to return the word address. So the dictionary has a bunch of entries that have headers, and the first row in the header is the pointer to the rest of the dictionary. The second row or second cell is the name of the dictionary item. The third one is the address of the function that corresponds to the dictionary, or address of the pointer to the function, I should say. And if we find that, then we'll return that value in line 60 and 61. We'll compute the value and then jump to the end. So we'll have the pointer to the, or word address as it's known. Okay, back to line 52. If we go down and we have not found it, then we're not going to jump to L found. We're going to move to the next item in the list. So X10 is that pointer to the search dictionary. That LDR is going to move it to the next pointer, and we'll branch back to the top and keep looking. And then finally, however you exit, we have an epilogue that restores those registers we want to modify. The next thing we worked on was tokenize, and we have another loop for this. So the goal with this is if you have a string with words separated by a single space, what we want to do is turn those single spaces into zeros, nil bytes, and we want to put an extra space on the end. So there's, in effect, a null string after our last string, or after our last word. And so the loop there, 27, well, tokenized loop is going to be the overall loop to keep moving till we find end of the string. Okay, so we're using C-style strings. So we're going to look at, in 28, we're going to look at the word the character we're at and see if that's a 0 byte. If it is, then we're going to do tokenize exit, line 45. That'll paste the extra 0 byte at the end of the string and return. Otherwise, we're going to see if it's a space, and if it's a space, we're going to store the 0 byte in there. So 33 stores a 0 byte at that location in the string. If it's not a space, we're going to check if it's a new line, and if it's a new line, we're also going to zap out the character corresponding to it. That's usually the last byte of our string coming in. And then if we move there, if we got to tokenize, move to next, after we've done our zeroing or not zeroing, we're going to skip forward one, branch back to the top of the loop. So the loop is basically, while we're not empty string, replace spaces if possible, replace new lines if possible, and skip ahead one character and go for the rest until you get to the end of the string. I don't think this tokenizer is going to be the permanent solution to things, but it was just enough to get us multiple words on a line. To get our implementation working, we had taken an approach that ended up treating lines, reading a line, and finding the word very separately. And so I'm modifying that approach. I want to combine those. So it's more like you go out and say, give me the next word, and you don't worry about, are you on a new line or the same line or whatever. So for now, the tokenize is on hold. We'll work next week to get multiple words on a line again. All right, next one is eval. So the evaluation piece of things. The routine eval itself exists, but it has that end of line detection behavior. So I'm not going to worry about that. We're really trying to get rid of that. Eval is pretty straightforward. Again, 47 is just storing the procedure prologue. And what we're going to do is we're going to take the argument in X0. That's going to be a word that presumably is going to be in our dictionary. So we'll do a dictionary search. And if it's a 0 coming back, we're going to execute 52 and 53, which those two load an address from the system dictionary. 53 adds 40 to it to move it forward to the first entry in the dictionary, which is always an error handling routine. And so we'll set up X0 to point to that. If it was found in the dictionary, then we already have X0. The dictionary search returns us a pointer to the address of the code. So we load that address and then branch through the register to get there. And that, in effect, finds, you've found some word to call, whether it's an error handler or the regular word you want, and we'll call that code, and that's the job of eval, find that one thing. In the future, eval will evolve. We also need to set up a compiling mode. So if some cases you're going to be compiling and you just want to do dictionary lookups, you don't want and store the value in a block of code somewhere, kind of building up the assembly output if you want. In those cases, we're not going to run those words until later. So the code in 56 and 57 is going to be conditional on, are we in compiler mode or execution mode? All right. And then once you have eval and kind of the rest, we're going to put together REPL, the read eval print loop. 83, 84, again, are just procedure prologue. The loop part is at 86, and that's kind of the top of things. We're going to print a prompt. It's just 10 greater because it's the 10th language. So that'll be our prompt. And then we'll call read word. That'll get the next word. Right now it assumes one word per line, but again, we're going to get back to multiple words per line. Given that word, it'll be an X0. That's where eval1 wants it. So we'll call eval1 with that word. And then 97, we're going to print. The fourth language, they just use a dot. You put a dot in when you want to print, and we'll adopt something similar to that. But for now, we don't have that word in our repertoire, among many others. We only have a very limited repertoire at this point. But so we can tell what's going on, we're going to print the top of the stack. So there's a prefix, which is something like top of stack colon. And then we call in 101, we call to print that number. And in 104, there's a suffix. I think it's just a new line, and we print that. So there you can kind of see REPL in there. You got maybe it's PREPL because you got a prompt first, read, eval, print. And then in 108, we go back to the top of the loop, and we just keep going with that. We don't have a way to exit right now other than Control C. I'm more interested in the problems I'm not 100% sure how to solve, and that one I think is solvable. At any rate, if you were to find a way to exit in 110, you'd restore the register you'd use and do a return. And it's funny to me, we've been doing this project, I don't know what we're on for episodes, but a few weeks. And now is the first week we decided to put together the REPL loop, and I wish I'd done it before. We could have done it probably in the second week, maybe. I don't know, somewhere in there to get something minimal going, even if it was just one word that we know how to execute. I've described last time, we have primaries and secondaries and all that. I really should have taken primaries and then put in REPL and got something working, because it just feels so much more real once you get to that point of having that interactive loop. Even if it can't do much yet, it'll do more. All right, and I'd like to move to a demo. First, I'll just run make, get a clean build. And we are using make. All these are our tests so far. So one of our early tasks was implementing a bare minimum assert equal kind of thing. And we have tests that check all kinds of stuff. Not everything, because I don't really do the IO stuff directly with these tests. I did some manual tests, but for each kind of thing, we have some real tests. So I don't know. You can see string length and then string EQ, decimal to string, and some stack ones, some arithmetic. Then this week we did dictionary, so a lot of stuff around that, some things around tokenize, and the basic interpreter. And then finally some things for REPL. I'm not quite sure we want to leave those the same. They're really testing eval. And again, I'm not, testing eval it's really just does this word work. All the other stuff with multiple words and all that, that's really more kind of the whole system test. All right, and let's run this. All right, so there's the prompt. And we don't have a lot of words. So what we have is one, duplicate, add, subtract, and multiply. I think that's it. I'm going to at least put in a program for let's multiply 2 by 3, and we'll take that as our task. So 1. Now normally I could do 1 dupe add. I'd at least get 2 on the stack. Okay, so 1, and then dupe is going to turn 1 into 1 1 on the stack. And if I add, I'll get a 2 on the stack. Now, if I push 1 1 1, all right, so I have 2 1 1 1. I'm going to do add. All right, so I have a 3 on top of the stack followed by a 2, and multiply should give me 6. All right. I know in some ways it doesn't seem like much, but it just feels so much more real to be here. If we could do multiple words, I think we could make little programs that kind of make sense. Every task we chose to do, we could say what words are missing. Oh, I don't have divide yet. Let's add that. I don't have mod. I don't have if statements or whatever, but the pieces are basically there. I think if we get the multi-word thing going as kind of a convenience, I'm going to switch over and look at more building up new words then and compiling. Next week, we're going to work on it, multiple words per line with a different input approach that's more focused on the input module will own the next word, getting the next word, rather than kind of cooperating between the input and the eval. Then we're going to look at the compiler. This notion, it has the notion of always execute words. So there's a word that says start compiling, and that word is going to be executed directly, but it's going to trigger the mode that doesn't always execute. So other words that get referenced. So if we said define sub 1 as 1 dupe sub, well, 1 dupe sub would put x minus 1 on top of the stack, I guess, and leave x there. And if you wanted to define that word, the definition keyword is going to be colon. So colon sub 1 says define sub 1. And we don't want sub 1 to be executed. It doesn't even exist yet. And then the word after that is 1 dupe sub. Each of those words, we want to just push them into an execution area. We're creating one of these secondaries. So the definition process builds the code block in line. Those words all will be looked up and saved, not executed. And then the next token may be a semicolon, which says that what we just did was build a block, finish compiling that, and go back to the execute directly mode. And so if we then typed 1 dupe add, those words will be executed as we go. All right, it'll make more sense as we go. And then finally, we want to start filling out system provided words. So we definitely need the rest of arithmetic, if and while, and maybe repeat. And I haven't addressed strings yet. I haven't addressed variables. I haven't addressed arrays. There's plenty of elements of the language that should be there. My hope is we can get to the language, define a small test framework, and then write a small program that's probably a calculator or a game or something about that size, just to kind of prove out that everything's hanging together. And the whole thing will then be a demo of, we built something from pretty low system level stuff. All we're using right now is the Unix exit, the read word. I think that's it. So I read a line. At some point we'll want to do open so we can do files and close, and there'll be a few others, but that's a pretty minimal kernel that we're building on. So that's part of the fun for me. I've wanted to do that for a while. If you feel like joining us, we're Monday through Thursday, 2 to 4:30 p.m. It'll be Eastern Daylight Time, as Sunday the 10th, the U.S. goes back to Daylight Savings Time, or 7 to 9:30 p.m. UTC. You can find me live at xp123.com/Twitch. That'll bounce you over to Twitch. Or you can find the delayed issues, the old sessions delayed and edited at xp123.com/YouTube. All right, thanks for joining. Bye-bye.